Alright guys, welcome to chapter 3. I honestly can't remember what the title of chapter 3 is. Sorry, graphing linear functions, okay? In the first section, page 59 of your student journal is just functions. We're going to learn what a function is and what that looks like. It can be represented a few ways. Sorry about that. An equation, an input-output table, using words, a graph, or a set of ordered pairs. That's quite a number of ways, 1, 2, 3, 4, 5, and we'll just explore them together. So before we do that, I'm going to go ahead and cover these definitions. I know last chapter we didn't cover many definitions. To be honest, you could have done without and still understood the material pretty well. But functions are a little new, so we should cover them anyways. So relation is just a set of ordered pairs. And when I say ordered pairs, well, pair means two. So that really just refers to ordered pairs x and y. For instance, 1, 5, 2, 6, 3, 1, 4, 2, whatever. It's just a set of x and y. So this is just an example. A function is a relation, which means a set of ordered pairs. A relation where each input has exactly one output. So for instance, you saw in the last one, I said 1, 5, 2, 6, 3, 1, 4, 2. That applies here as well. Something that would be a no-no, so a poor example, and would be something like this. So an input is typically x, and the output is y. But if I have another ordered pair that is the same input but with a different output, that doesn't work because now this input 1 has two different outputs, 5 and 7. So that does not work. And just so we are clear, I will put an x through that. Okay, no good. A domain is the set. So I'm looking for the writing tool. The set of inputs. So just x, really. And the range is the set of outputs, y. So domain and range are interchangeable with x and y, really, or at least, yeah. Okay, so those are those definitions. We'll keep moving. Along with domain and range and x and y, independent variable and dependent variable are also pretty much the same thing as far as I understand it. The independent variable is a variable, typically x, that does not depend on another variable to change. What does that mean? Independent means, I mean, if you think about like an independent person, they do whatever they want, right? So in most functions, x is whatever you want it to be. It is totally not dependent on y. However, depending on what x is, then y will change accordingly. So a variable, typically y, that depends on another variable to change. Down in these notes, I'll do a brief example. Let's say we have a function that says y equals 2x. That means whatever I replace x with, I will multiply it by 2, and that will be my y. So more examples using this same function, y equals 2x. If I say x equals 2, let's pick a different number so it doesn't confuse you. If x equals 5, then y equals 2 times 5, and we have the ordered pair. X comes first, which is 5, and y is 2 times 5. That is 10. Following along with the same function, pick a different number for x. If x equals 8, then y equals 2 times 8 now, and we have the ordered pair 8, 16. So in this case, again, I am changing x however I please. and the thing that changes according to x, depending on x, is y. So there's your little example. Copy it as you need to, and we will move on. Core concepts. The vertical line test. A graph represents a function when no vertical line passes through more than one point on the graph. So on the left, this counts as a function y. If I made a bunch of lines, which I'm about to do, this only passes through one point. This doesn't pass through any points. This only passes through one point. Again, this only passes through one point, and the vertical line test just applies across the board. So imagine me making like a million lines like this, and at no point will any of these lines touch more than one point, right? That's what makes it a function. Each x only has one y. However, if we look at this, this is not a function because a straight line, boom, hits it twice, hits this graph twice. So this vertical line, boom, hits it twice. It doesn't have to be exactly twice. If it hits 3 times, that does not count. For instance, if I had something that looked like this, and I do the vertical line test, here it looks passing, but here it fails. So if the graph fails the vertical line test at any point, then it does not work. So even something like, let's say this, if I just double back a little bit, then here it passes, it passes, it passes, but here it fails. It hits it twice. Or here it fails because it hits it twice, and that's not okay. Okay, so that's the graph representation of that. Domain is the set of all possible input values. I must have said something along those lines. The range of a function is the set of all possible values. Again, the domain is tied to the input x, and the range is tied to the output y. So let's look at this here. Determine whether the relation is a function, explain. So in this case, the definition of a function is, and I'll write it right here in case you forgot, each input has only one specific output. Each input, y. Each input is an x, by the way, so each x has only one specific output, y. So if you have x that shows up twice and it has the same y, that's okay. If you have the same x twice but it has a different y, not okay. So let's look at this. -2, 0, 1, -2. The only one that is even the same that we need to look at is -2. And would you look at that? 4 is one output, and 5 is the other output. 4 and 5 are not the same, so this is not a function. This is not a function because the input -2 has two distinct outputs, 4 and 5. It should only have one. So if there was a 4 there, right here, that would be fine because it would just be 4 and 4, and that's the same thing. If this instead was a 5, and that was a 5, that would also work. If they're the same thing, it still constitutes a function. If it is not, then it does not. So here, if we look at this, the input is x. So don't forget that the input is x. The input is x, 0, 1, 2, 3. Well, we don't even have a chance to see if any of these inputs have any repeaters or different numbers because they're all different. So yes, this is a function because each input has a distinct output. Moving on. Now we're just going to use the vertical line test. So let's start here. It passes in here. Well, would you look at that? It goes through two separate points. Does that count? No, it does not. So no, it failed. This graph fails the vertical line test by touching on 2 points in one line. here, let's see, we have a line here that touches one time. We have a line here that touches one time. We have a line here that touches one time. We have a line here that touches one time. We have a line here that touches one time. And it should be apparent that none of those lines is going to touch one once. So yes, this graph is a function. It passes the vertical line test. No line touches more than, oops, no line touches more than 1 point. And that's it. In exercises 5 and 6, find the domain and range. So again, the domain is tied with x, and the range is y. So here, I'll say x. And because it's not a connected line, then it is distinct integers. So we have x is 0, 1, 2, 3, 4, and 5, not 6. The range, which is the y, I should have done that for x as well, but it's okay. Range y, 3 and 4. That's it. Now, if I write this out as an ordered pair, I will write things like 0, 4, 1, 4, 2, 4. Each input has an output. The outputs are not different from each other, but because one input does not have two different outputs, this is okay. Like, it still passes the vertical line test, right? So it's still a function. Pretend my lines are actually making it through those points. Here we go. It's still a function. Each line only passes through 1 point. Each straight vertical line only passes through 1 point. So you can see that even though they have the same output, they have the same y's, this still counts as a function. Next, this is also a function. The domain is, let's see, the domain x is from -3 to 3. Another way to write that is -3 to 3. Another way to write that is, oh no, I can't do integers, so this is still okay. Y is the range y, and we started off at 0. This is it, and the highest we go up to is 1, 2, 3. So the range is 1 through 3, and that's it. So moving on. Okay, the function represents the number of y of pages of text a computer can print in x minutes. So let's just think about this before we before I just answer it for you. So you should think and ask yourself, okay, does the number of pages that is printed depend on the number of minutes you have, or does the number of minutes you have depend on the number of pages you are printing? All right, so let's say you're running late to class. Let's say you're running late to class and you need to print an essay. If you're late to class, does the amount of paper you can print depend on how late you are, or does the number of papers that you're printing determine how late you are? Okay, so I know I worded it kind of funny. Maybe it was hard for you to listen to and wrap your mind around that. In any case, in this problem, the independent variable is the number of minutes, or x, and the dependent variable is, let's say, number of pages. Number of pages printable. The domain is x is 1, 2, 3, and 4, which means that 4 separate times I'm going to plug in a number. I'm going to replace x with each of these separate numbers. 1, 2, 3, and 4. And I get y equals 12, y equals 24, y equals 36, and y equals 48. Intuitively, this should make sense because if it's happening 12 it basically is printing 12 pages a minute, right? So the range is 12. Sorry, y equals 12, 24, 36, and 48. All right, guys, that's the end of this lesson. I know it's can be confusing, but really, I don't think it's crazy. It's a crazy concept. Basically, when you think about it, if I had to wrap it up or analogize it to something, a function essentially represents a monogamous relationship where each input can only have one output. Like each person can only have one significant other. I'm not saying that's the truth or anything like that. I'm just saying that's an analogy that you can use to think about it if you so please.